Good afternoon, and thank you, Victoria, for my introduction here for this first afternoon session at the Appleton Space Conference. I would like to give you a couple of examples of how we can actually use spaceborne data in our quest to tackle climate change. But first of all, I would like to say a few words for motivation, really, because I will concentrate more on the cryospheric aspect, on the sea level aspect in my presentation, having seen that my subsequent speakers will cover different spheres of the different parts of our planet that are affected by climate change. Now, this summer I had the privilege to go on a expedition to a glacier in Switzerland near Zermatt. It's the Gorner Glacier, is one of the biggest glaciers in Switzerland, and we went there to actually film a documentary together with our ESA Web TV, but also with one of our astronauts, Luca Parmitano. And here you can see a couple of images, and that was very interesting because this glacier in particular, when you look here at in the middle of it, this map here has actually retreated to a large extent. It was down here quite close to Zermatt in 1850, and it has now retreated quite high up here. One of the sort of eye-opening moments was when I bought a map from the equivalent of what is in England probably the Ordnance Survey. It was from 2015, and the glacier actually location that was shown in the map was nowhere near where it was in these days. So that really gave me the impression of how fast this development of retreating glaciers, of melting glaciers is actually ongoing at the moment. The other thing that I found very interesting on this expedition was that we went also in some caves underneath the glacier, and that really brought the message back that we might be seeing a lot of things from space, but you know what we see from space and how it actually translates to the phenomena that we see on ground needs careful consideration and translation in many ways. So in many ways, this was a very eye-opening expedition for me, and a very motivating one for my current position, obviously, as the head of the climate office in the European Space Agency. And I will come back to this one. But what I wanted to start off right now is that over the last couple of months, we have seen a number of events and reports being released which have a high impact on our thinking about the impact of climate change. Most recently, we had the COP26 meeting in Glasgow a couple of weeks ago, and this meeting in particular focused on the 1.5 degree Celsius challenge. So the Paris Agreement, is of course concentrating on limiting global warming to 2 degrees and, if possible, to 1.5 degrees. And the UK presidency had picked up on the 1.5 degree Celsius challenge. But that was also sort of recognizing that at the moment, actually, the need is to deliver a 45 cut to global anthropogenic CO2 emissions by 2030, and then net zero by the mid-century. But if you really look at the current development of this, and that is what you see on the right-hand side in this comparison of emission scenarios to the NDCs, so the National Determined Contribution. So basically the limits that each and every country under the Paris Agreement has set themselves, then we see actually that we have a 13.7% rise in greenhouse gas emissions level by 2030. So the curves that you see there over the time on the x-axis tell you something about the different scenarios. So you see in blue the lower 2 degree scenario. So if we were to implement or reduce emissions to limit the global warming to 2 degrees, and then the 1.5 at the upper limit and the 1.5 at the lower limit. But the top curve that you see there in yellow is basically saying that with the current pledges that we have on a national level, we will not be able to do that, and we will actually rise our greenhouse gas emissions at a particular percentage, or better to say, not enough percentage to actually reach our pledges of the cut by 2030 and net zero by the mid-century. So this really gives us the motivation to carry on with this work, a need for a rapid and deep and sustained reduction in global greenhouse gas emissions based on the best available science that we have at the moment available. And this is really where the work of, for example, the European Space Agency and the Climate Office come in collaboration, of course, with our large climate change initiative community. Having said that, there were also a couple of decisions being taken at COP26. I think there were three main ones that are, on a, let's say, larger level of impact. The first one was the Declaration on Forest and Land Use. So that was a deal that was subscribed by more than 130 countries to halt and reverse the forest loss and land degradation by 2030. And that deal would actually cover something like 90% of the world's forest areas. There was also a global methane pledge to cut emissions by 30% over 2020-2030, so over the next decade, and move to the best available inventory and methodologies to quantify these emissions, because that's important under the global stocktake that is coming our way in 2023, when we for the first time will really look how successful we have been in implementing our individual national and regional pledges to reduce emissions. And then there was also other aspects being discussed, for example, the transitioning away from coal, so phasing out of oil and gas production, ending finance for fossil fuel overseas, and so on. One of the other discussion points that we've also seen, in addition to the three that I've just outlined here, is also the funding of how we can actually provide sufficient financial support to, for example, developing countries to tackle the impact of climate change. So that, just in a nutshell, is a little bit of a summary of what came out of COP26. I thought that was important maybe to put that at the front of this presentation. Another important publication that we have seen over the last couple of months is, of course, the release of the Intergovernmental Panel of Climate Change, IPCC Assessment Report 6, from the first working group, so the working group that's actually focusing on the physical evidence base. And that was released in August, and it essentially confirmed what we have seen before, so that the human influence has warmed the atmosphere, ocean, and land, and that's something that we have seen also in previous assessment reports. But one of the major messages, I think, of this particular working group one reports was that this warming is actually accelerating, and that's a major message to keep in mind. And the way that that was found out, and this is sort of coming back to how we can actually use space data to tackle climate change, is that methodological advances and new data sets contributed approximately to 0.1 degrees Celsius to the updated estimate of warming in Assessment Report 6. And this is very much linked back to the use of space data in formulating all the outcomes under this particular report. Now, observing the Earth from space has a number of advantages. It's long-term, so some of our data sets are 30, 40 years long coming from space. They're continuous, they're very timely, so you can go to the same spot on Earth in a number of days only sometimes. They're global, and sometimes they're co-located. So basically, if you have on one satellite, say Sentinel-3, three different instruments that are measuring the surface of the Earth at the same time, but with different techniques, you will have a multitude of information above a particular point on Earth. So there's numerous advantages to observing the Earth from space. ESA is essentially catering for the entire, I call it, food chain of addressing providing space data for climate change. The core business, of course, in the Earth observation program of ESA is to develop and implement Earth observation missions. We have a number of missions in operations now and under development and in preparation. And they come in different flavors. We have one-off missions that look at new scientific questions and new technologies, like, for instance, the Earth Explorers, which you see here on the left-hand side. But we also have the ones that look more towards continuity of providing particular space data over a number of years, and that is very much linked to the Copernicus program and the Sentinels that have now being launched since almost a decade, and we will of course have further missions coming in the future, and then also the meteorological missions that we're building on behalf of EUMETSAT. At the moment, we are looking very much towards expanding the current fleet of Sentinel missions into the future. One of the missions that is probably of utmost importance for the global stocktake that is coming our way under the Paris Agreement in 2023, the first one 2028. The second one is the CO2M, the anthropogenic CO2 monitoring mission, which is one of the missions that the community is looking forward very much, because it will give us very important measurements of CO2 that we need in terms of quantifying the emissions under the global stocktake. But there's also 5 other missions that we're currently looking at, addressing different aspects of a changing climate over the cryosphere, over the Arctic, more geared towards maybe the impact in terms of agricultural impacts that we are seeing, and urban management, food security, and also vegetation and ground and ocean. Vegetation being, of course, important, because one of the aspects is not just quantifying the emissions that we're doing, but also having an idea about the AFALU, so the agriculture, forest, and land use changes that we are seeing, which is also one aspect of the reporting under the Paris Agreement. Now, just to give you a little focus on what we're actually doing in our office, we have sort of 2 heads, I would say. We are implementing the Climate Change Initiative, which is our flagship program, which you see here on the right-hand side, basically addressing the WMO-defined essential climate variables, of which there's 54 at the moment. Roughly more than a half is sort of benefiting from space observations, and we are addressing at the moment 21 of them. You can download these data from our open data portal, which you will find the link on from our website here on climate.asa.int. We're also making a very active link to the modeling community via our climate modeling user group, and we're also looking across different ECV data sets, and I will come to that in a minute. But we're also having a more, let's say, policy remit in our office. So we are representing ESA's interest on the International Climate Network, and there's different stakeholders from a more policy perspective, like for instance the EU or UNFCCC and IPCC, more from a service aspect, like for instance the Copernicus services and ECMWF, and from a sort of scientific point of view with the likes of GCOS and WCLP. And we are an observer to IPCC and UNFCCC. We have had quite a huge impact on the last IPCC report from Working Group 1, as you can see here. So this is the different IPCC reports that we have been seeing over the years. You see on the x-axis, and on the y-axis you see our impact in terms of referenced papers and publications that comes out of our CCI projects. But we're also contributing to a large extent to the writing of the report itself by having many of our science leads and people involved in our CCI projects being authors, lead authors, coordinating authors, contributing authors, and also reviewers of this, for example, the assessment report 6, which actually combines more than 14,000 references that have been assessed in putting this report together, which is a huge endeavor and very precise and built on very precise science. Just to give you a few examples of what we're doing, having said that, my other speakers in this session will probably look on different spheres, I thought I'd put something in and come back to my initial slide and tell you something about glaciers and sea level rise. Of course, glaciers are important contribution to sea level rise. About 20% of the sea level rise that we're seeing at the moment is attributed to glacier melting. And here in particular, you see a map on the right-hand side, which comes from a paper from Huguenot et al., which was published this year in Nature, where we are we're assessing all the different glaciers worldwide. There's more than 200,000 glaciers worldwide. Only a small subset of them is actually studied in detail, let's say. But now that we have space data, you can actually map them in a different way. And you see here, you know, the contribution that they actually provide to the melting of these glaciers worldwide. So that's something that has been using CCI methodology and processing tools, and is a very important input to our assessment of how glaciers contribute to sea level rise. And of course, why is sea level rise important? It has a very hands-on impact, of course, on in particular coastal areas, as you can see here from the publication, which basically shows you an example of Shanghai when we have 3 degrees Celsius warming and how the city would actually look like. So this is a very hands-on impact that we need to manage in the future. Here you see our long-term series of sea level rise, which actually is combining different data sets. The sea level rise comes, of course, from melting ice sheets, glaciers, for example, but also comes from thermal expansion. And that was clearly referenced also in the IPCC report, Working Group 1, which you can see here, the citation on the right-hand side. Sea level rise is measured mainly by altimeters, of course. And here we are combining different altimeter missions that we have launched over the years, collaborating internationally to form one single data set that actually tells us something about it. And again here, as I said at the beginning, we are seeing an acceleration of sea level rise over different decades. And that's a very interesting result that we're seeing here and need to be aware of also for our adaptation measures, taking into account our scientific results. Sea level rise is not the same everywhere. It does actually depend on where you are. It does depend on the temperature of the seawater. It does depend on ocean currents, on different wind systems, on gravitational adjustments, and so on. And these ancillary information we can also provide with different satellite data from space that we have currently available. And my last example, also sort of continuing on the topic of sea level rise, we have been looking into relative sea level rise. So, for example, if you look at the top left here, because of the melting glaciers and ice sheets, the continent of North America is relatively lifting up, offsetting the sea level rise that we're actually seeing. So this is, you know, a relative sea level rise, whereas we see the opposite effect in Southeast Asia, where we have more subsidence, which of course then makes the effect of sea level rise even more drastic. So this is an interesting thing, how we can actually put together different information to provide actionable information for national, regional, and local governments to address the impact of climate change. And then last but not least, I would like to say, where are we going in the future? We have the Paris Agreement. We know that we have to address certain aspects under the Paris Agreement. We need to do reporting. We need to reduce our emissions to actually keep well below the 2-degree warming. But we also need to make an effort to actually translate these global policies into regional and national actionable information. And I think this is probably the challenge that we are focusing over the next decade, very, very hands-on. This think globally local is something that one of our science leads, Chris Merchant, has actually labeled, which I like very much, because it really makes the point of needing to think about the connection of global policies onto a regional, national level, and translating it into, for example, national determined contributions and national adaptation plans. My last slide, little outlook. We are currently discussing our new climate program, which we have already presented to our ESA member states a couple of weeks ago, and it was very supportive. I think what we're looking at in the new climate program is really to maintain and expand the portfolio of high quality essential climate variables that we have put in place and that are accessible. and are being used and already transitioned also in the operational world under the Copernicus Climate Change Service. But we also want to look forward a little bit more and help our member states to respond to the UNFCCC Paris Agreement and their reporting requirements under the Paris Agreement. And the second big aspect of the new climate program will also be to link more the climate observation and modeling communities. ESA has been selected to host the World Climate Research Program's Coupled Model Intercomparison project. The project office at EXAT, we are currently selecting it, and there will be an announcement soon who's going to be the director and the office. And hopefully they will be in place by the beginning of 2022. And we're very much looking forward to working with CMIP, which I think is, obviously the one of the major flagship programs under the WCRP program, and the sort of gold standard of climate modeling intercomparison, which also has a huge impact and contribution to the IPCC reports. And just to make you aware, we have our Living Planet Symposium next year in Germany, the last week of May. And if you're interested to contribute to that one, there's a number of climate-related sessions in there. If you want to submit any abstracts, and the program will be published very soon, also with a very dedicated climate day, where we will have panel sessions and discussions on burning issues, as we are discussing also here this afternoon. So thank you very much, and I hope you enjoyed this presentation, and happy to take any questions.
Thank you very much, Susanne. That was a really interesting overview, and it's really clear that these long-term quality control climate data sets are essential for monitoring and understanding how everything is evolving over the coming years, as well as in the past. I must say I was very envious of your trip to Zermatt. It's a lovely place. We've just got time for one quick question. In your view, which one future mission do you think is going to have the most impact on measuring climate and providing evidence for policymakers?
That's a very good question, and not an easy one to answer. What I would say is we have reporting obligations, like under the Paris Agreement for particular emissions, and there we have the CO2 emission, for example, but we also have other emissions that measure, for example, methane, like Sentinel-5P, GOSAT, etc. There's different missions that actually measure the things that we need to see under reporting obligations, but then there's a large fleet of missions that actually measure the impact of a changing climate, and this is the data that we will need to put our own adaptation plans and national determined contributions in place to be able to react to the effect that a changing climate has. So I wouldn't single out one of them, but I would basically say there's different types of importance depending on reporting or adaptation measures, really, for us.